In the video, we talked about the introduction of air quality. This issue I dug out from my previous accessories. In order to find out my air quality, turned up a bunch of these displays. You can see its original packaging looks like this, and 2 pence. This one should have higher performance. And it's a little bigger than a screen. And I made this for you. 3D printed shell. You can take it out and take a look. He's just like him. But I 3D printed it myself and put it inside. Then stick and you hold it there, so it's a little TV. I did a YouTube fan counter. I can also reuse it now. Then you can also display the weather forecast. Display the temperature at home. Micro Python. This is what I researched before. Homemade display. Before I saw this display online. I learned the code by myself. ESP32 S3 8 GB of storage, 8 GB of flash memory with our GT9030 or something like that. The screen is 3.5 inches, and then the wires here are all connected. And then there's the screen. And you'll see it looks a lot like this. Then this screen will be smaller. But this screen, its personality can be much higher than it. So let's say the total cost is the total cost. If you want the same performance, ESP32 plus this screen, it might cost $10. But all this might add up to is only $6, half less. And its performance is very sufficient. Its color quality is also very high. But compared to him, the only thing he has is this board is very thin. Then all are designed by professional engineers. So I'll do it. Even if I don't add a shell, I directly put it on the wall. Connect the power. I can be the display screen of my smart home or some other display. And then because it's thin enough, so I can print it thin enough, 3D printed shell. It also looks thin enough. Then it's like a little TV. This costs, so it might cost about $1. I might make it into a weather forecast later, or the YouTube fan counter, or some other message notification. Now just showing it here, this is a small screen, maybe 2.5 inches. This 3.5 inch one. This is 3.5 inches. This is the 2.5 inch one. This may be ESP32 S3. This is ESP32. If it is displayed on the network or in MicroPython, LGY, its performance may not be enough. Only some local displays can be done. It is best not to connect to the internet or graphics processing. If you use touch, you must use C language. The circuit design in it is not supported. The same goes for this one. If touch, you must use C language. Its limit assembly design is not supported. This is good. This is because the wire is connected by itself. It has touch wires here, and the performance of this ESP32 is the top. So whether you are connected to the internet, learn LVGL or touch, or do whatever you want, it's absolutely sufficient on all of these. The only drawback is that it's thick enough. The suggestion here is you can buy it without stitches. This ESP32 without pins, this display without pins, and then solder it in. This line connects here, then the height of the needle will be gone. Yes, only this size is the same as this box. Then the same can also be made into a shell, and it won't come loose because of this pin, and cause your code to run unsuccessfully. For example, this one is already crooked. Yes, so try to solder it. And this is the shell I designed myself. On existing products, someone else took a professional engineer. It took hundreds of hours, or designed with professional technical skills. This circuit, you just need to apply. The only thing you want to be beautiful is if you had only designed acrylic shells. If this plastic shell was not designed, you can 3D print it yourself. If you have 3D printing at home, you can set one up yourself. This is what I designed myself, but my 3D printer is too old. The one from 6 years ago, 7 or 8 years ago, has been thrown away if there is demand or revenue behind it. I would buy a 3D printer. Take our previous temperature and humidity. Area set with its own box. Okay, that's it for today's video.